Statistics. All right, we're looking at statistics, and statistics, it's really nice, really nice. All right, so it says a group of students estimated the mass of a seed and the cumulative frequency is shown by this graph. So they give us the ogive graph or the cumulative frequency graph, and they want us to use the cumulative frequency to estimate the median. The median is what they call Q2. And so what you're going to do is look on the y-axis and you notice that it is 100. The median is associated halfway, so you're going to go down to 50. This is known as the position of Q2. The position of Q2. Position of Q2. This is where the median is going to be associated or located. Then you're going to draw a line over. When you draw your line over, you get that it's right here. Then what that means now is that Q2, which is the median, you draw a line from this point going down. So draw a line from this point going down, and this will be the median. So the median is looking to be, this looks like 3.2. 3.2, excelente. This is 3.2. That's 3.2. So that's the median. The median is equal to 3.2 using the graph. Nice and easy, soft. They're giving away marks. So that's the median. Now, the next thing they want us to do is to find the upper quartile. To find the upper, and then they want us to find the semi-interquartile range. So let's just do two of them in one. So to find the upper quartile, that's 3/4 of the maximum. 3/4 of the maximum 100 is, of course, 75. So we're gonna locate 75. 75 is gonna be, this is 72. This is, let me zoom in. This is 72. This is 74. Then somewhere here is 75. Somewhere here is 75. That connector right here. All right, that's right there. So this is the position of the upper quartile, and the upper quartile, they generally call it the position of Q3. Position of Q3. Q3 just means upper quartile. Lower quartile, they generally call that Q1. Don't ask me how they come up with where should be Q3 and Q1, but that's what they do. And now what you're going to do now is you're just going to draw the line going down. I want to make sure it's very straight. So it's right here. So that looks like 4.2, I would say 4.3. I'm going with 4.3. So that's the upper quartile right there, 4.3. The upper quartile is 4.3 from our graph, that is. So we're getting 4.3 for the upper quartile. All right, so let's go around here. We jot that down that the upper quartile is 4.3. Now that we get the upper quartile, we need the semi-interquartile range. Now the semi-interquartile range, I like to call it SIQR. The semi-interquartile range is equal to the interquartile range divided by 2. This is a formula we need to remember. It's an interquartile range and we divide that by 2. Now, what is the interquartile range? The interquartile range is Q3 minus Q1. It's the upper quartile minus the lower quartile. That will give us the interquartile range. All right. So this is the formula we use to find the semi-interquartile range. So only thing we need to do now is to go ahead and find the position of Q1 and then find Q1. Now, of course, where is going to be Q1? The position of Q1 is going to be at a quarter of 100, and a quarter of bills, it's 25. So we go 22, 24, 25. 25 look like somewhere in here. Somewhere here. Now my line, of course, is not so straight. Let me try straighten it. Yeah, this looks a little bit better. So right here, so we call this the position of Q1, P of Q1. And so what am I getting? I'm getting that the position of Q1 is going to be associated. Let's change the color for now. Position of Q1 is going to be associated with, this look like 2.2. All right, that look like 2.2. That is 2.2. So that's the interquartile range. Now we know the interquartile range because we know Q1. Q1 is 2.2. So the semi-interquartile range is going to be equal to Q3, which we found above was 4.3. Then we minus our interquartile range, and we said our interquartile, or Q1, our upper quartile minus our lower quartile, and our upper quartile is 4.3. We subtract our lower quartile 2.2, and that will give us the interquartile range. Then you divide it by 2 to get the semi-interquartile range. The final answer I am getting is 4.3 minus 2.2 divided by 2. I'm getting 1.05. That's my semi-interquartile range. Nice. Now, part 5. Part 5 says, find the number of students whose estimate is 2.8 grams or less. So go to the graph, I'll need to find 2.8 grams or less. So what you're going to do is you're going to look for where is 2.8. You're going to draw a line going up from 2.8. That seems to be right here. Then you connect it across. And so what that tells us roughly is that, let me straighten the line. So roughly 40 students, approximately 40 students is 2.8 grams or less, because this is where it is connected to. All right. So approximately 40 students or less go with 2.8 grams. Number of students whose estimate is 2.8 grams or less, that's 40 students. All right, 40 students. 40 students, nice and easy, soft. The statistics question was so soft. Nice. All right, nice. Now finish the stats question. Well, the first part of it, that is. And now let's go ahead and do this now. It says, using the cumulative frequency on the previous page, we need to complete this table. So M is the mass, so it said that 20 people is between 0 and 2. Oh, use the curve. So we're going to fill this out. We know that the total frequency was 100. So, all right, let's use the curve to complete this portion of the table. How many people are there between 2 and 4? How many people are there between 4 and 6? All right. So, of course, again, I'm going to change the color of the line that we're going to use. Let's go ahead and use green. We're going to use green as the color. So between 2 and 4. So between 2 and 4. This is 2. This is 3. This is 4. And I draw a line going up and up and up. So between 2 and 4 is going to be 20, and this is 70, and 70 minus 20, that's 30. Well, 70 minus 20, that's 50. My apologies for almost saying 30. Associated with this is 70. Associated with this green is 20. And 70 minus 20 is 30. So there are 30 persons that are between 2 and 4. All right, so we can go back to the table. We can go back and say there are 30 persons between 2 and 4. 30 people between 2 and 4. Now, after you get this 30, you need to know, go ahead and find how many persons are between 4 and 6. Now, what you could do is you could just say, since I already find what is the amount between 2 and 4, and I already know the total is 100, you could just say 50, 56, 57. This must be 43. It should be. It have to add up to 100. So just to play it safe, to show that it's going to be 43, you can go now and draw another green line between 4 and 6. So let's draw that green line between 4 and 6. So go up here, to draw a green line. I'll go across. Right here, so it's 93. Then we're going to go 93 minus 70. 93, between 4 and 6 is 93. I still wrote the wrong thing, you know. 70 minus 20 is 50. Oh gosh, my apologies. This right here should have been 50. I'm subtracting incorrectly. That should have been 50 right there. 70 minus 20 is 50. And now going from this green to this green, when we subtract, we're getting 93 minus 70, that's 23. So in this table right here, so it should be 23. So go in here, so it should be 23. Nice and easy. 23 goes here. Soft with a capital T. So that completes this table. It says now a student is chosen at random. A student is chosen at random. Find the probability that a student estimated the mass to be greater than 6 grams. So they want us to find the probability that a student chosen at random, any student chosen at random, that their mass is going to be greater than 6 grams. In order for their mass to be greater than 6 grams, it's going to be 6 plus 1 is 7, because there are only 7 students in total that have a mass that is greater than 6 grams. So it's going to be 7 out of the total number of students, which is 100. So the probability of a student being chosen randomly with a mass greater than 6 is 0.07. 0.07. And that's that. That is that for now. Easy question, soft, nice. And that takes care of this boring question. Okay, now let's continue.